please help us in welcoming Mauro Marconcin.
Thank you, everyone. First of all, I'd like to thank the Jeffs and the Auros organization for having us again. I mean, I'm really proud to be next to at least so far, the two great presenters. The first two presentations were really good, and I'm sure the next ones in the afternoon will be as good as those. So what I'd like to go through here is a little bit of our year 2 experience with Auros. As Jeff just said, we're dropping the TRW name as of this week, so we're going to be known as ZF only. So we've been using for about 2 years this tool right now within the design community. So a little bit of what we're going to be covered today. We're going to give a quick background, what Auros, or what our company is, what Auros is in our work, and what is our vision for the Engineering FBE. We're going to see these 3 letters a lot. It means Foundation Brakes Engineering that we're representing right here. So Chris McCormick is our chief engineer. He's here again this year. He was here last year. And number 3 will be design reviews in Auros, something that I take a lot of pride on. I think we did a really good job over the past year. 4 would be the knowledge capture using in support of parametric modeling. And we're going to have 2 other presenters. Tom Valvano is going to show something really similar to what Tim presented in terms of knowledge enhanced decision making. So it's really a decision making use of CAPEX for the design engineer. So there are points in the design that somebody needs to know which material to use, which feature to use. So Tom is going to go with a little bit more details what that's going to be. We have Saikiran from our friction material team that is going to go through his work in Auros, and we're going to have some closing remarks. First of all, I would like to go really quickly in this slide. I know I was made fun of Tom to put this in, but I wanted to find something interesting about the word knowledge, and trying to find some etymology on this stuff. And basically, it can be broken down in know and ledge. Know is more like know, perceive, recognize. I really like the fact that it's opposed to opinion. So it's something like it lacks opinion. It's really a fact. And the ledge part is just action. So it's fair to say it's the process to seek truth. I mean, we're throwing another word, knowledge. We went through the information age where people are saying information is important, data is important. Now we have this another catchphrase that Jeff Moffa wants us to buy from, right, Jeff? It's knowledge. Knowledge is the most important thing you need to have. So, and it's important to actually know for your company what is not knowledge. I think that's what we learned over these years. I mean, some people want to put everything in Auros, and maybe there is already a better place for some of the pieces of the data that we have out there. I really like the other word that describes knowledge, which is wisdom. It's something like what you do, what you have in front of you. So you have a lot of information. Let's say you want to bake a cake. So you have the information, and with that information, you're going to apply your tacit learning, and you're going to make something useful, something delicious in this case. So moving on. I just want to show really quickly what kind of product we're talking about. In terms of the products that we do, we really work with brake calipers, rotors or brake discs, parking brakes, and cast iron hubs. And what we have here is basically 2 examples of the products that we have, some of the main products that we work on. One is the conventional caliper. What is shown here is a twin piston design caliper, mostly used on bigger cars, bigger trucks. And we also have one example of our electric parking brake, or EPB. It's a product that is really taking off right now. So what we have in Auros is mainly related at this point to this type of products. We do have some knowledge in the other 3 products that we work on, but mainly what we've worked on for these past years has been on these 2 products because they represent maybe 90–95% of what we do. So there's a lot of challenges when we're trying to go through knowledge capture applied to brakes. Once we're doing the brake design, one of the first things that we look at is to minimize brake drag. I don't intend this to be like a heavily an engineering discussion, but I just want to point out some of the challenges that we have in terms of knowledge capture. Brake drag is important to reduce or eliminate because it directly relates to fuel economy in your car. The next one will be lightweight design. So we're trying to achieve the customer requirements at a lower cost and also with a reduced mass. Only enough mass because that also translates to fuel economy in the car. And we need to make sure things are not going to break, especially when it comes to brakes, right? So we need to make sure it's reliable and it has proper safety requirements met. And it has adequate stiffness. This is related to the pedal feel. Every time you're pressing your brake pedal, you don't want to like put your foot all the way to the floor. You want to make sure you have responsive brakes. And finally, we need to be near zero noise. I know we hear in movies a lot when the cars are braking, you hear that squeal. It's very characteristic. People don't like that. I mean, maybe they like in movies, but it doesn't work well in real life. So we want to work to minimize, to bring comfort to the driver and to the occupants, or to the dogs that are in the car. So a good brake design is when everything is met on time and within a competitive cost. The really key for the success here is when we accumulate knowledge of decades of engineers doing studies on their own, testing, calculations, and they come up with good solutions for all of those attributes. Obviously, in our test plan, we have a lot more than this, but I was just trying to summarize in the main topics here. So what is key is to make sure we collect that knowledge in a structured way. So people come and go. That's another challenge that we have. Like I think Tim mentioned, we have good people, but oftentimes they have to move on. They have to move on with their careers or retire sometimes. So the main challenge here is or the treasure of intellectual property is to how to collect that information and apply to everybody else. So if people can close that gap on the chart that Tim presented there, and we can really tap into the experience of others. I like this quote a lot. I kind of stumble upon this, and it's related to knowledge. And it says, knowledge is of no value unless you put it into practice. I think it has a lot to do with the chart on the right, because we can capture knowledge, but if you really don't apply it, we don't have that continuous validation and refinement of the knowledge. And we experienced that firsthand this year, as you guys are going to see in our organization, when we're doing assessments for actual projects. That's when we saw that the standards that we use to design brakes are really, I shouldn't say not great, but they are really not up to speed to some of the things, or all of the customers are using that. So it allowed us to refine the knowledge, correct that knowledge, update it a lot more. So here I have a couple of things that happened over the last year. I'm not going to go through all the details here, but we are really busy. And this to me is really good. So last year, we trained most of our people in Auros. We had like 5 awareness sessions where about 80% of the people got into the training. I mean, Chris might remember that because I used a lot the character of the angry chief engineer on some of the illustrations for that training. So to illustrate recurring errors and stuff. So don't get angry at me, Chris, please. And we had pilots on design reviews last year, and we had this year also. So we got teams, and we trained them in assessments, and we really, what we're trying to do is really ignite the process of the design reviews within our organization. One day, Chris came to me like, what can we do to make sure we don't have mistakes reoccurring? Then what I said is like, let's do design reviews, and Auros is the best tool for that. So that's when we put this into place, and people really embraced it. And the one thing that I was really glad to see that for all the meetings, everybody that was called in showed up. Even upper management, all the managements across the different areas of expertise, they showed up for every single meeting, and the meetings were really productive. So I'm gonna go over in the next slides a little bit what that experience is all about, and hopefully you guys can benefit from our experience. We also have one of the main specs to design a caliper completely loaded into Auros, and not only loaded, but we have explanation why things the way they are. So oftentimes, engineers can see like, oh, there's a spec, this wall thickness needs to be minimum 5 millimeters. And you just follow it blindly. But what we're trying to put is in there is like a justification for that knowledge. Why is 5 millimeter? Where was this tested? When it failed? So how to apply to your design. So like bringing people not only automatically meeting requirements, but the people to understand why these requirements are in place, and maybe even sometimes challenge those requirements for specific projects there. So this was successfully completed last year, or this year I should say. And also one thing that was really important that was done this year, there was a presentation for our engineering VP, and really the decision was made to use Auros as our main knowledge management system within foundation break engineering. So this is the main vision for it. I mean, I was really glad. I consider this a personal success, working with this knowledge management system for over about 2 years now, where we're able to really convince our upper management that this is the way to go. And now Auros is almost in everybody's mouth. Everybody is saying for new processes, when we're trying to rethink the way we do things, Auros is right there. And I guess just touching on the last bullet points, we have our European folks, our German counterparts, the other design center that we work very closely. They are also adopting it, and they are in their implementation phase right now. I have a couple of slides actually that I think Jeff mentioned yesterday about the library model. And I guess before I go into this stuff, I must say that in our building, we have an actual library. We have a room that was purposed to be, and it's called the break library. There are books there. But how many can guess how many people go there and look for books and look for knowledge and really apply to their designs? I don't know. I checked out a book maybe 10 years ago, and it's still with me there on bolts, and nobody noticed that I did that. So I don't think people are using it actively. The idea was great, and the information in those books, I'm sure it's very good, but it's a perfect illustration why a library model doesn't work, and we actually have a library now. Maybe you can repurpose to have a new cafeteria or something. I don't know. So this is typically what it is. We have for product development process several gates to go through, and we're expecting people to go to that library and search for information. So there's a lot of problems with this stuff. I'm not going to read it all, but as Jeff mentioned yesterday, it's not efficient, and people have to spend a lot of time going through this. A lot of people don't go look for information, so there's a lot of issues with that. So what Auros brings is a new way of doing things. So it's combining all that information in terms of CAPEX and assessments. So we have a structured way to capture knowledge, and we have a structured way to deploy the knowledge on demand. So we're going to see here some expressions of knowledge on demand. That is exactly what the previous presentation is all about. It's the knowledge in the flow of work, or KIT-F. Maybe we can call it just like that, right? I'm just trying to create a new acronym here. So this is exactly what Auros is going to bring to our company. So in terms of CAPEX and assessment controls to structure this, I just did this a comparison in terms of the conventional approach and the Auros approach. And what we have, the first question when you find a nugget of information, a nugget of knowledge, is this, where is it? So sometimes the knowledge is very difficult to find, or it's not reliable located. Oh, I have it on this email, I have it on the network drive, it's on my hard drive. So it's really difficult to find the stuff, it's not globally available. So with Auros, we have an easy and reliable location for this type of information. Again, the second one, is it reliable? As I said, you find an email with a PowerPoint or a spec. I don't know if it's the latest one. I don't know if it's being revised, or maybe somebody's gonna go by, oh no, I really don't like that spec. I have another one that is better. So you really are unsure how to go by in your design there. So with Auros, you are sure that the information is there, passed through an approval process, so people really looked into this stuff and they put some time to put quality information in it. Also with the conventional approach and the Auros approach, is the information, the knowledge used, we really don't know if that guideline that you put together or that design target is used across the board. You put it in an email, send it to everyone, how the design manager knows that everybody is applying it. He really doesn't know. I mean, Auros, through the assessment, gives you a tool to really deploy the knowledge and collect the results to be able to make sure your knowledge is being used. And the last one, is it protected? I mean, I think the answer for the conventional approach is really straightforward. We really don't know where the emails are going once you send them out. With Auros, we have the ability to protect through two ways. You have an access control through a login information, even the data in transit, you can encrypt the data in transit. So we have two levels of protection in here. Here are the main life cycles for knowledge management. The reason I put this slide here, I don't want to go through this in too many details, but there are really three areas that people are looking for in terms of process in the system. One is the community of practice, the CAPEX creation, and the approval process, and the other one is the assessment. The one thing that we're finding that we need to define a lot better now is we need to ask ourselves questions of who's going to create, who's going to maintain and approve every single piece of these three processes there. So that's something that needs to be well defined, and we're still working on this stuff. We're trying to get global agreement, and it's really important, man. I mean, we can have CAPEX created, but not being useful. Or even worse, the information there is wrong. So we need to make sure all these CAPEX, all these assessments are done. They are processed by proper people, so we have a formal approval process for this stuff. In terms of design reviews, I have a couple of slides. They're going to illustrate a little bit what we're doing here. Why we're doing design reviews? Because it's in our development process. It's something that we need to make sure that the designs are going out there, meet the latest guidelines so we don't have mistakes going on. Also, it enables the design teams to bring attention to problems that they have with the design. So it draws management attention to specific applications. Let's say I have a caliper design, but I'm not really able to meet a specific requirement because a packaging constraint or a specific customer requirement. So the design reviews are a tool to have that as red. So reds are not bad. I mean, I keep saying, some people say, oh, my project needs to have all greens. Reds are not bad because the reds are going to allow people to focus on the right points, get those work done, and bring them to closure. So I think a project with a lot of reds is not necessarily a bad thing. And also allows to refresh the knowledge, refine it, and improve it by using it. So we have our agreement right now that our design supervisor are going to use it. We're handing this information to them, and it's working right now. And we also have some ground rules to keep this design reviews meeting going on. I'm not going to go through much detail, but one thing that we need to focus on is that the design reviews are meant to identify problems, not to solve them. As engineers, we're trying to come up with solutions on the fly. Oh, why did you put a larger radius here? Why did you use a different material there? I mean, we allow some of these discussions during the design reviews, but the main focus is to identify issues and identify people and timing to work on this stuff. So otherwise, these meetings can last 4 or 5 hours easily. So we're trying to make them really snappy, really productive. So one thing that we are trying to define for design reviews, and we define it really well, is in terms of what's the setting. We have people in a room, we need to make sure everybody knows their roles in terms of the design reviews. First of all, we have a facilitator. Somebody is going to call the meeting, define the agenda for the meeting, make sure the material is going to be brought in for everybody to review, maybe even before the meeting. So, and most of the time, the facilitator is going to be a timekeeper. We want to keep these meetings at 1 hour, 60 minutes, and we're able to do that. This person opens and closes the meeting with a very short statement and define what's going to happen next after the meeting. We can define, this is an optional role, a note taker, somebody just to take notes along the way. And there is going to be a main presenter. Typically, it's a lead designer is going to prepare the material, present the material, and the design to the team. Is going to answer technical questions, and the Auros assessment will be evaluated by this person, and then there's going to be a portion where the Auros assessment will take place. There's going to be a knowledge representative, somebody that's going to take notes with issues on the CAPEX. I mean, we know that the CAPEX are not going to be perfect. We found out. I mean, and this is good. So we actually defined one of the conformance states to be problems with the knowledge. It's called the KR, or knowledge review. So that's where this person is gonna take notes and bring it back to the knowledge team to reinforce the rules there. And the others are gonna be subject matter experts. They're gonna be experienced peers, engineering managers, anybody that we feel it's important to go over this design review. So here's just a quick overview how this whole process falls. Typically, we make sure that every team has a training in the assessment. They really know what buttons to click in the Auros system. We have meeting one. It's actually an optional meeting where we call the team preparing the material to help them out if they want to evaluate or fill out the assessments during this meeting. We're going to go with them to make sure they know how to do it, make sure the information is correct. And the meeting number 2 is the one I just mentioned. It's going to be the actual design review. Then we have time to 1 hour, and we have a structure for the meeting. And at the end, we need, the goal is to have the assessment completed, so closed. Even if there are like red items that are going to be carried to another phase, but there's going to be action items identified for each one of those issues, and we need to make sure we comply to this. I mean, this is really important because it's related to the look across. I believe Nick from FCA mentioned the importance of the look across. The only way we're going to have quality look across if these assessments are completed and completed with correct information with quality. So we also need to make sure the information on the assessments was completed correctly there. So here's just like a quick review. The meeting itself has an agenda. I'm not going to go over all the details, but this was really important to keep a pace on the meeting. Every single step has a duration on it, so we need to make sure people come in, they present the program they're working on. There are some main topics that we want to see before going to the Auros assessment. And at the end, we want to have some closing remarks to identify who's going to work on what, specific issues. So this really helped keep the focus on the meeting. So having an agenda, I mean, it seems like very basic, but Several times we are going to meetings, nobody has an agenda, nobody knows what's going to be talked about, and we spend 1 hour or two, and okay, what came out of it? And we almost felt like we wasted time there. So this way, we really know what to do. We really know how much time we have for every single step. The other important aspect that I'm going to touch here, and then Tom is going to present it next, is going to be our knowledge capture for CAD parametric modeling. I cannot think of, for design engineers, a better tool to have knowledge and demand than the CAD model. I mean, when the design engineer is working, he's typically working 99% of his time in CAD modeling. So he's going to be defining wall thicknesses, clearances. I mean, he's going to be defining the shape that is going to fit, the caliper is going to fit under the wheel. So everything goes down to the CAD modeling. So we need to make sure the design engineers are given clear rules and guidelines. And right now, we have kind of like a separate way, like the library model. There are specs here, and then we have our CAD model. We have some sort of a parametric modeling that has rules embedded, which help us a lot. But we're really going for the next level, which is using Auros to manage all the rules, all the design rules, and introduce them, infuse them directly into the CAD model. So a couple of things that I want to touch here is like when somebody is designing a caliper or any kind of system, there's going to be several decisions to be made. So we have, in this case here, which material to pick to better perform function. Cast iron, aluminum, we can have both. So somebody needs to make a decision which one is going to make. So what are the rules? What are the guidelines that we can give our people to make the right decisions? It's going to depend on the specific needs for the program. So there's going to be a decision-making process that really, when Tom comes here and presents this stuff was really borrowed from algorithms that the financial companies use, the big companies use to make large scale decisions. So sometimes the decision is not straightforward. I mean, we may pick a cast iron for durability, but it's going to be heavier. So in engineering, we often find ourselves with trade-offs. So we make something better, but we make something worse. So there's an optimum point to be achieved. I think Chris says about the whack-a-mole game, right? So you walk one, the other one jumps up, so the engineer keeps playing around that. So what we're trying to achieve here is a structured way to make decisions during the design process. And Tom is going to present us in a little bit. So there are several decisions to be made, and right now we identified about 40 or 45 important decision points for brake calipers. So we have this really well mapped out, and we have this work done. So it's a work in progress right now. So what I have here is just an illustration of how this is going to go. So basically, we're going to have Auros as a centralized place for design guidelines and rules. Other thing that's important, the parameters definition is going to be clear there. So oftentimes we cannot use parameters across different systems for some things that are very simple because the parameter names are different. Sometimes people are called the rotor thickness or the disc thickness or disc wall thickness. If you change the name from one system to the other, you cannot make the communication between the systems. So we're trying to standardize names, standardize the definition. The Auros CAPEX are going to give us the ability to add pictures. So define better what those parameters are. So we're going through this work right now. And standardizing the terms, the functions, the component names. So Auros also has been chosen as a repository for all that standardization. Again, we're providing the design flow. So there's a way to start the design. So we identified which features we need to start when you're designing a caliper there. And then also provides an education for new people coming in. So with this structured tool, people really can learn about the system. So with the parametric model, it's going to give you the geometry that meets those guidelines, and the rules will be enforced for all the design centers. Lessons learned and the how and whys are going to be there. And this is going to enable us to have a faster design turnaround and something that meets the requirements. So with that, I'm going to ask Tom Valvano to come in, and he's going to present a little bit an example about the selection criteria CAPEX.
Perfect. All right. Thank you, Mauro. So once again, I'm Tom Valvano, and you and I, we make decisions every day. Some of the decisions are very easy, like in Auros, we can go use a value table to look up the size of a bolt. Other decisions are quite not so direct, and these are actually decisions that we want to address and tackle within Auros. In fact, we actually created a special CAPEX name called Selection Criteria CAPEX, just to house all of those. And for us, for ZF, it's a new concept in making design-related decisions. So we'll start with the current condition. As a brake supplier, we have specific customer performance requirements that can lead to conflicting product features. We have, well, that doesn't work. Anyway, high fuel economy, high strength, low cost, they're all very popular parameters, but they can conflict with each other. I mean, I can have, oh, I did that by mistake, sorry. I can come up with a design alternative that's great for high fuel economy, high strength, but it's not necessarily going to be the cheapest. So what we have to do is this type of decision really requires a trade-off analysis to actually come up with a decision. So in this current condition, we have design decisions that are being made by product engineers based off of their experience and their own understanding of the guidelines. So as you'd expect, these decisions are going to be inconsistent between product engineers. We have new engineers. They don't have the experience to really base these decisions on, so they don't have the knowledge to make the logical design decisions. So they're actually going to require a lot of help from the expertise. Well, we had a vision, and the vision was to go and try to support this parametric model that Mauro had just talked about. The vision was to develop a decision-making tool within Auros to guide these product engineers in making design decisions based on specific customer criteria and the knowledge of our product. The next decision was, or vision was, to have the tool reside all within Auros. To be honest, I was actually starting the structure of this whole tool within Excel with a bunch of hyperlinks going to Auros. And to say it was disconnected or it felt disconnected is kind of a good example or a good feeling I had, because what I was doing is I was going between two programs all the time. And when there's a lot of work to go between programs, I'm one that wants to look at the easy path, and I start forgetting mostly about doing the Auros part. That's the important information. So our vision was that that whole tool had to reside within Auros. And finally, the tool must be able to avoid specific design alternatives if there's some known conflicts that occur with other design features. Let me give you an example. Let's say I want to make a decision on a dinner menu for a group of friends, and I know one of those friends has a nut allergy. Well, then logically, I'm going to exclude any menus that have peanuts in it. That's no different than what we want to do with brakes. I have a set of design alternatives, and if I know one has a conflict with a feature, I want to be able to exclude it from the pool. That's what we wanted to accomplish in the vision within Auros. So this essentially here is our decision-making process that we're developing within Auros. It's actually made up of 3 blocks. The first block on the left is criteria. All complex decisions require a criteria to base a decision on, to determine which design alternative fits that need. In addition, just to, well, I put in here, yeah, high fuel economy, high strength, low cost. That's what I had on the previous slide. But in addition to just defining those criteria, we actually need to now rank the criteria as far as their relative importance. Maybe they're all equally the same, but maybe 1 or 2 of them are more important than the other. So there's a ranking and a value applied to that. The center block is essentially where all our knowledge comes in. This is, that block is essentially all of our design alternatives for this decision. And we know how that design performs. We understand it, we know how it performs relative to the criteria, and all that information is housed within the KPACs. We have the design alternatives that we need for customer requirements to meet the internal requirements. The KPACs also house all of our individual experiences. And then once again, we talked about the design constraints. That all has to be handled within the KPACs. And then in the end, the box on the right, we need a design decision that understands the design alternative performance relative to all those criteria. So it's a lot of words. Let me see if I can give an example to show you what we actually are developing. So I have a really important decision to make. Which car do I buy? Actually, yeah, everything got a little resized, but so which car do I buy? I start off with my product criteria. Minimize the cost, maximize fuel economy, maximize utility, and maximize the wow factor. That's not a Shane Red X reference. It's really that when you see that car of your dreams pass you by on the highway, it's a wow. So we have those criteria. Now we need to define a value for them. So what I think I chose 1 to 10, where 1 is the lowest importance, 10 is the highest importance. Now note that what I think is important isn't not necessarily what Mauro thinks is important. So it's going to be customer specific. And once again, our result has to be able to accommodate that. Design alternatives, I have my hybrid car, got my Model T, got my utility van, and my sports car. Those are my alternatives that I have for my decision. The thumbs up section, that's all our knowledge. That's what our understanding is of each design alternative relative to that criteria. For instance, if I look at max fuel economy, the hybrid, our knowledge tells us that hybrid gets our 4 thumbs up. And unfortunately, that sports car gets only the 1. All of that is housed within KPACs and easily accessible. Once again, if I'm in Excel, I have to go between programs. But if it's all in Auros, it's all easily accessible. And then in the end, I have a design decision that has looked and evaluated all of the criteria value and the design alternatives. Essentially, it's a weighted value. So now I've put in a design constraint, and I want to color in chartreuse. And for those that don't know what chartreuse is, it's actually a little off that color, but it's a lime green color. Well, we all know that the Model T came in any color you want it, as long as it was black. So I need to be able to exclude that design alternative from our pool. And that is all handled within the KPACs, such that my end result, the green car, the hybrid, is now my true design recommendation. And this is what we're then passing on to our CAD tools. This is how we're passing on the information, the design recommendation right into the CAD parametric tool to design and develop our part. Now I'm going to give Sai a couple minutes. Thank you.
Okay, thank you, Tom. So I think last year we presented about what we did in the friction engineering team at ZF. So some people might not know, you might know brake pads, but I just want to explain. So our team, we mainly work on developing a brake pad, the shims, which are mainly for the noise fixes. It looks very simple. I mean, for a person who is not working in a braking industry, they think, what's the big deal with a brake pad? That's how I thought. And when I first met my wife, she was like, what are you doing? And I said, I develop brake pads. And I said, that's all you do. So, but if you really see, it's a very, very important component in the brake system. What we did last year was we created this friction COP where we inputted all the design guidelines, and then we mainly divided the COP, the friction COP, into 3 main categories. One is the friction material requirements standards category, the other one is lessons learned, and the other one is best practices. And then we were also able to give some training using that Auros. And then we use the Auros system to actually track our global project updates. So our friction engineering team, we have in Europe, we have in China, we have in Japan, and we have in the US. So how we collaborate, Auros has been a very good platform for us to collaborate easily. And then we also came up with how we establish the KPAC and how it flows through the process. And we had a rough RASIC that was established. The reason I say rough RASIC is each location has its own requirements based on customers in Europe and China. So we are still in the process of commonizing, having a single RASIC for the whole friction team globally. Then what we do, once we established that, as Mauro was stating, there are several issues that we face when we are doing brake development. And in every issue, if you see what Mauro explained, like low drag, noise, durability, everywhere you have friction involved. So friction being the last in the food chain, and it's the one that comes in contact with the rotor, so they get beaten the most. So you really need to develop the friction very robust, and the process has to be really mature so that you have very less issues. So for that purpose, we thought that we should actually start doing these assessments where we will bring in all the friction checklist into the assessments. That way the friction engineers don't miss on any important detail. Because if you see a day-to-day work of a friction engineer, they have to go through a lot of data from different suppliers, shim data, friction data, and there are a lot of parameters that they need to check in testing, in looking at the physical data and all this stuff. So there are many chances of them missing 1 or 2 single points. And even when we are doing the reviews, there are many chances that we can miss those. And those things, those small things, which if missed, can cost big when we are at during production or PV stage. So late last year, what we did was we created this assessment with all the friction checklist. And then the goal was the whole global friction team should start using it. Now, when we brought this idea, everybody liked it. That, oh yeah, we got to do this. So we did a pilot in the North American team. And then each friction engineer chose a program that they are working on, and they did the assessment for that. So majority of the people, they had a very good feedback that they like this, it's going to help them. We had some people who thought that it's an extra work. We had some people who thought it was neutral. So our idea was, this was the same in our global teams as well, in Europe and China. So since the majority likes it, and I think our direction is to use this as our knowledge management tool, after this pilot, now we are starting to incorporate in our regular work. So this year, our goal is basically to do the checklist on every program during DV, PV, and before PPAP or during the launch. The idea is to have all the checklist green at the end of PV stage. So in DV, there might be some issues that they might not, they didn't fix it, or they're still working to fix it, but when we come to the PV stage, we should have all the green stuff. And then you can see we have, in this assessment, we are able to add comments, we are able to add documents to that particular friction requirement. So any issues, how they solved it, or did they use an existing KPAC or existing knowledge packet to solve this issue? Or did they come up with a new knowledge or a new way to solve it? Everything can be documented. And once we think that, okay, we came up with a new method to solve this issue, that will go into as a knowledge packet, new knowledge packet, and that will be tied to the respective design requirement. So we want to do this and see how it's improving our development process so that we are making less mistakes, or we are able to capture the mistakes early in the program. Another main thing is the friction engineers, when they are in meetings, they get asked a lot of questions about what friction material to use for this program, or what do you think about this? And many times they have to tell it from their memory, or they have to really go back and check their documents in the database, and it takes some time. So what we anticipate with this checklist is basically, you can use the same friction material for different programs, and you can have different issues. It can work on one program, but on another program you can have another issue. But when you're doing these assessments, say we use friction material 1 during CV, DV, PV stage for project 1, project 2, project 3, then this assessment can capture, it can have a common issue, like say, for example, stiction issue. Stiction is nothing but like pads sticking to your rotor when you park it for 2 weeks, maybe in an airport or something. So that can be a common issue on all the 3 programs. Then the friction engineer is well informed that, okay, if I'm choosing this material, this is the issue I'm going to face. And those assessments will have how it was solved. The other thing it also helps is, like how it was solved. So for example, they solved the stiction issue, and then, okay, they're going to the next program. Maybe they still want to use this friction material only, but then because of some noise issue or something, they are forced to use this, but then what are the alternatives I need to do? And they can sort out using just a friction material, a keyword, and they can actually have a well-informed answer for the customer when they are being asked. So that's our goal, and I think next year we hope to have enough assessments done on all the programs, and we want to see how it has improved our efficiency of the team, and then we want to roll it over to global as well. So that's about the friction stuff we did this year. So for closing thoughts, I'll give it back to Mauro.
Okay, I just have 38 more slides to go through before lunch. I'm sure you guys are not hungry. And I just want to close with a couple of things. We still have a lot of work to do, have a lot of process to go through and work instructions to write. I mean, I really like the first point of this morning that the goal to be here is to learn how to market this product, this Auros, this idea within their company. I want to say that the biggest thing is persistence and patience. I mean, we are where we are because we have to try different things. You have to persist. You have to always be willing to change your way. If it doesn't work one approach, try a different approach, but never give up. I mean, it's not easy to introduce a new concept, a new system within a company, but the main thing is like persistence there. So this is the lessons learned from applying this. The future looks bright from our end. We have strong support from upper management for global implementation. As a matter of fact, Auros was just selected as one of the main metrics for our projects to be measured against. So every single engineers need to be engineers should need to be shown an assessment complete for its project. So this is a great success for us. We have engineers in Europe being trained, and they are using this stuff right now. And our progression has been steady and growing every time. So this is the chart that when you get to Auros, you see the activity. So when we were called into work was in the beginning of 2016, and that's where you can see the patient is getting back to life. So we're seeing a steady growth on this stuff. And I must acknowledge some people here. Tom and Sai been helping a lot. Alvin White is here. He has helped a lot with this implementation on the project. We wouldn't be here without him. Alex helped as well. Chris is a big promoter of the tool across the different design centers. And we have people in Europe and in China also helping us with this progress there. So can I have any questions you guys have? I don't have any live polling, but if you have any questions for any of us here, or you guys are too hungry for that? I'm sorry, I can't hear from. Well, I must say that we're really small. What we decided to do, we picked our one spec with our main design guidelines. Luckily, we had a very well-organized spec where our main guidelines are, and we decided to pick that. So we transformed that into CAPEX and into assessments. We have more specs to go through. So in terms of percentage, I mean, number of specs is probably not even 10%, but the importance of them maybe were 50 to 60%. And in North America, we start getting more and more adoption. We still have to increase the consumption of the knowledge. We don't have many people in a daily basis going there and looking for stuff. That's what we're hoping with the design reviews, kind of like putting in the flow of work to having people like, oh, if you need to do this, you better know what is in there. So then people will kind of like, I hate to use this word, forced to find out. So we still have a lot of work to do. I mean, there's a lot of challenges ahead of us, but we are much better now than a year ago, I must say.
A quick one on your design. You just mentioned design reviews. One of the things I noticed was that didn't look cross-functional as far as manufacturing, other areas, purchasing, quality. Just wondered how you guys are going to handle that, and I think that's the basic question I had there. We try to do a lot of collaborative engineering. So
this is a great question, and we are encouraging more and more in the other departments to come in. Manufacturing was invited to come in, as the friction material has its. So we have the design team, you have the development team, but you're correct. I mean, we have to bring more people. We're not cross-function as we would like to be. So this involves other departments to embrace the tool, to creating CAPEX and building in. So we're trying to first organize our home, our design home, but I understand what you're saying, and we're trying to promote and more the use of the tool to other departments there. I think we had a question here.
Yeah, maybe a question for Sai that I think was talking about China or testing or trying to apply it in China. I was just wondering how the latency impacts the use of Auros. I assume the server is here in the US, so I'm just wondering if there is a difference in the way that it would be operated in China compared to what we do here in the US.
No, I think, as I said, that's why we want to come up with a RASIC for the global team. Our idea is really not to be totally different from China or US. We would incorporate some of the local stuff that only pertains to China. But then as the process and everything, we really want to be global and same. So we have one engineering center in Europe. So we have mainly 3 friction engineering centers, big engineering centers, one in North America, Europe, and China. And we want to be pretty much the same. Did I answer your question? Yeah, so, yeah, so China has not still started using it like really how we are using. Even we are going to start using it now with these assessments. So I cannot answer that question now. Maybe next year I can have some answer for that.
Any other questions? I don't know if you have much time, but I'll give it another one. If not, before Jeff kicks me out, I should say. Tom Valvano is going to present the cool K-Pack after lunch. I'm sure you have room in your car for the trophy right now, so it's going to be related to the selection criteria, so make sure you vote for Tom. Thanks, everyone.